Hello everyone. So this is Debabrata once again with a new class, and today my aim is to show you some of the complicated programmings over the matrix app that is also being called as a matrix application. So I will not waste my time. As you know, these classes are the intended audience of these classes are the students who are really struggling with their syllabus. So and I would not waste my time by introducing my introduction. All the details will be available in the detail section of this video, so you can go through those links. So if I want to jump quickly into the topic today, so and that is matrix application in Java. So we have already covered the basic operations of the matrix. So as per prerequisite, you have to go through the starting from zero. You have to go through the previous class of matrix, where I have shown how to deal with the matrix, how to take input, how to print them and all. And obviously you have to take some time and you have to go through all of those exercises, and exercises links are also available in the detailed section of this video, as well as at the end of the class you will be also able to find those links. So if I go to the topic one, that is a matrix application, some complicated programming over the matrix. So the first program, if I choose today, and I am considering that you know how to take the inputs and you know the basic operations of the matrix. If not, I would request you to revisit the last class and solve the exercise for the matrix and then come into this chapter. So for the first program, it is saying enter a matrix and check if it is an identity matrix or not. So for the identity, what is identity matrix? Let me show you. So mathematically, an identity matrix is what? Like the diagonal of the matrix should be 1. So if you check the diagonal elements of this matrix is all of them are 1, and non-diagonal elements of this matrix are 0. So that combination you need to maintain. So that you need to maintain. So what I can do now, so and it should be a square matrix as well. So first I will take some input. Okay, let me go to the Google and go to the onlinegdp.com or anything, any online softwares or even any softwares you can use. I prefer to go through those online one because I do not need to install anything. I can quickly go to go there and print my type my programs. So that's why I prefer those. So if I write the program, suppose import java.util.start to take some inputs. I think you all are aware of this, how to take the inputs and all. So system.in scanner, and after that I can prompt like enter the size. As it is a square matrix, only one input will be enough. Enter the size of the matrix, and after that I can take that inside n, and I can prompt like enter the elements. Now these things we know we have checked in the last class, but still int I equals to 0. Okay, let me type the program. It will take some time to take those inputs. So now I think the input section is okay. So what I will do, I can take a variable like f equals to 1. I am assuming that the matrix is an identity matrix. Now, as usual, I will browse through all the elements using the same loop. I can go through the matrix using the same loop, and I can check if suppose I equals to j, means it is the diagonal one. If it is the diagonal and aij somehow is not equals to 1, then I would mark that as f equals to 0. Say else if I will do this. I will check another one, another time. Like if it is not diagonal, else if it is not diagonal and means I not equals to j, but aij is not equals to 0, means when it is not diagonal and it is not 0, I would like to mark it even at that time. So at the end, if it can stand still with the value of f equals to 1, that means it is identity. So at the end, if I check the value is still 1, it didn't become a 0. So I can comment like it is the identity matrix because I haven't found any exception. All the time when it is diagonal, all the time it is 1. Because I was continuously checking. If it is not 1, I would like to mark. Even when it is not diagonal, it is not 0. I was always checking that. But if it's still at last the value of f is still 1, that means it is the identity matrix. I hope this idea is clear. So this is an identity matrix. And in else part, I can write it is not an identity matrix. Okay. This is not an identity matrix. So if I would like to run the program, how it will behave, let me show you. Okay, some mistakes I have done. Okay, I have not introduced the matrix itself. So my bad. So int a, int n and n. Yeah. Sorry. Yeah. I guess it is okay now. And everything I have covered. Yep. So if I go through a 3-size matrix and elements are 1, 0, 0, 0, 1, 0, 0, 0, 1, it should prompt it is an identity matrix. If I make some exceptions like for the diagonal, like, okay, let me take 3 again and 1, 0, and I am putting some value like 2 here. And all the rest of the values are like an identity matrix, except that 2. And it should print this is not an identity. Because this place is not diagonal, that means I not equals to j. As well as the value of that place is not equals to 0. So this f would turn into 0. The initial value of f is 1, but here the value of f will turn into 0. And at the end, I am checking the value of f is still 1. Answer is no. The value of f has been changed to 0. That's why it will go to the else block and it will print that this is not an identity matrix. I hope the idea is clear. If it is clear, then I can go into the next program. If not, you can just write something in the comment box so that I can try to make you understand with some, I will try to help you over that if you are not able to understand. So the next program is shifting up. So what is shifting up? You can see here 10, 20, 30, 40, 50, 60, 70, 80, 90. The left side one is a input matrix. Okay. And now you can see all the rows are being shifted one place up. You can see that. And the first row is now at the last position, but all others row are shifted one position up. So if I can write the program of to solve this requirement, how to do. So first I will take the backup of the first row. What I am trying to mean, I will try to take the backup of this first row, and after that each and every row I will try to shift it up. Okay, so I will try to shift it up here. But the first row I will take the backup. It has 3 parts. In the first part, I will take the backup of the first row. In the second part, I will shift up all the rows. And the last part, the third part is I will again restore the backup array into the last row of the matrix. Okay, so let me do that. So if I write a first thing, so this is the first step, and the shifting will be the second step, And third step will be restore it back into the last row of the matrix. So this is the third step. So first, let me start with the taking the backup. So if I go to the program window, okay, and let it be the square matrix. You can do it with any type of matrix as well, but let it be the square matrix for the easiness of the program. Then you will be also able to understand it in a good way. You can try to do the same in your computer with some row and column with some uneven matrix as well. It is with some matrix which is not square, but for the timing, let me start with the square matrix. So what I will do first, after taking the input here, I will step one is back up the first row only, first row of matrix. So what I will do, I will first take a temporary array, or you can name it anything. It is a normal array, and where I will, the size of this array will be obviously in the column size, and the first row, I mean to say int I equals to 0 and I less than n and I equals to I plus 1. And I want to store that inside the temp array. So temp 0 means temp I will be taking the value of first row means 0, and the column will be iterating as I. Means 0 is fixed, it is denoting the first row. So the first value 0, 0 will be stored into temp 0. 0, 1 will be stored into temp 1. 0, 2 will be stored into temp 2, kind of that. Okay, so first step is done. We have taken the backup. Second step is shift one place up. How to do that? Let me copy this. For loop. So I equals to 0, I less than n, and j0, jn. So I will not perform it for the first row. I will start it from the second row. That means the value of I is 1. And what I will do? I will simply write a I minus 1 j equals to a I j. What does it mean? So I have started from 1. The I equals to 1. That means row 2. What I'm trying to mean, if I write some matrix here, suppose 10, 20, 30, 40, 10, 20, 30, 40, 50, 60, 70, 80, 90. So what I'm trying to do, I am trying to start with this row and all the columns, and I'm trying to copy that in the first place, means 40, 50, 60 here. So 40, the location is, if I write all the location here, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So 1, 0 element will be copied into 0, 0 element. So that's why I am writing a 0, 0 will be copied from a 1, 0. So here, if I write I, here it will be I minus 1. And obviously this value would be changing. This value would be j and j. So all the rows in the same column, all the rows value will be shifted to the previous row. That is my intention. I hope it is clear. So I am writing, that's why I am writing a I minus 1j equals to a I j. The columns will not be changed, only the rows will be shifted to the previous row. I will be shifted to the I minus 1 row. So the second step is also done. Now I will go into the last step, where I will be copying the temporary elements into the last row of matrix. Last row of the matrix means I have to copy the same loop once again. Just the difference is here a last row means n minus 1. a n minus 1 j will be equals to temp I. That's all. That's all what I can do. So last row n minus 1 0, the first element will be copied from temp 0, that is 10 in our example. After that last row it is fixed, j means j become 1. Okay, sorry, it will be 1 I, sorry, it will be I as well. So n minus 1 0 will be copied from temp 0, that is 10. N minus 1, it is fixed, it is the last row, and I become 1. So it will be copied from temp 1, that is 20 in our example. After that, 30 will be printed into the 2 position, and it will be coming from temp 2. Okay, because temp previously in the step 1, by using this step, I have backed up 10, 20, and 30 into this temporary array. So all of them will be printed into the last position. So now if I want to print them, print the full array, what it will be look like. I will print the full array now, full matrix, sorry. Both are same, but still I should name it as matrix. So print Aij, I guess. Yeah, Aij with a space. Let me put a system.out.println to we can enter after each line. So I can write something here as well, system.out.println the shifted matrices. If I do that and if I run the program, I think it should behave good, but still, let me take a look. I will go for a 3 size matrix. So I am taking the input. If I hit enter, you can see 10, 20, 30 has been shifted into the last place, and 40, 50, 60 has been promoted to the first row. 70, 80, 90 has been promoted to the second row. Previously, it was in the third row, and now it is being promoted into the second row. So hope this idea is clear. If not, you can let me know in the comment section. So it is being shifting up. Okay, now if anyone asks you to shift it up for the 2 places, so obviously, if anyone asks the same, so obviously, all these steps, I will put it into another for loop. All of them will be done twice. Okay, let me do that even. It is very small and very easy. If anyone requires to shift it up for the 2 positions, 2 times, so I will put all of them inside the loop, one big loop. Okay, and that's all, nothing and. Okay, so that's all. So all of these will be happening twice. That's all. So if I run the program once again, suppose I want to go with now 4 size of matrix, say 10, 20, 30, 35, 40, 50, 60, 65, 70, 80, 90, 95, 11, 22, 33, 44. If I do that, you can see 70, 80, 90 is promoted to row 1 from the third row, and 11, 22, 33, 44 has been from the last row, it was being promoted to the second row. First row became the last row and the second last row consecutively, and the second row here is being promoted to the last row because it was shifted 2 times. So I hope this idea is clear now. If not, just let me know in the comment section, or you can send me the mail as well. So if I go to the last part, transpose matrix, what is transpose matrix? It is also a mathematical term where you can see, if I draw a diagonal here, you can see the values, like the values beside this diagonal 20 came here. Just on this part of the diagonal. Okay, so if I take any other value, suppose let me take 30, you can take it is now at this position. So from one side of the diagonal, it is coming into the other part. So it is the transposing of a matrix, it is being called. So what is happening actually, the size, the 20, the position of the 20 in the input matrix is 0, 1, obviously 0 row 1 column. If you can think, this is 0, 1, the 20, the location. And now here it becomes 1 and 1, 0, right? For the 30, location is, at first it was 0, 2. And when in the output matrix, it becomes 2, 0. The location I'm talking about. I'm not talking about the value, it is 2, 0. I mean to say, it is something like this. The new value, new location of the 30 is 2, 0. So you can see the locations are being changing from ij to ji. Okay, same for this 70. The first part, or if you take 80 in the input value, the location of 80 was 2, 1. If you can think, the location of 80 in the input matrix. But here in the output matrix, if you check, it is in the first row and second column, because row and column starts from 0. So it is in row 1 and column 2. So just the value of I and j is being changing to j and I. And for the diagonal elements, you know, it is ij, I equals to j. So the value of I and j is same. So if I want to write this program in our compiler, so obviously enter the elements. I do not need to do anything here in this part. And here I can write like transpose matrix is, and before printing the matrix, I will like to shift the position. So what I will do, I will simply take another array, say int b. I can even shift the values here inside this matrix itself, but I want to make it more easier. I will take another matrix called b, and what I will do, it will be easier for you to understand. I will simply write b ji will be aij. I hope it is clear. bji equals to aij. And at last, I can do one simple thing, a equals to b. That's all. A will be taking the new value of b. So this is a very important line. You do not need to copy them again into A. So whatever is in B, that will be now inside A. Means A will be taking the full A, all the elements of B. And A will look like B now onwards. So now if I print the A array, you can see here I'm trying to print the A array. So if I want to print that, it should print properly. So let me show you. If I take 3 elements, 3 size, 10, 20, 30, 40, 50, 60, and 70, 80, 90, you can see the transpose matrix it is being changed. You can see that. 30 from this position, it is coming into this. 20 from this position coming into this. Okay. And the diagonals are unchanged. 10, 10, 50, and 90 is unchanged. I hope this idea is clear now. Okay, again, if not, you can contact me over the mail or over the comment section anywhere. So mirror image is like if you put a mirror in between these two, you can find these are the mirror image. If this violet line is a mirror, you can think 30 is coming here. 20 from there, it is coming to that part. So what if I want to write a program for this? You can see 30 is at this position. So it is a mirror image. I think I do not have to say much about what is mirror image. So you can see that. So how I can write this program? The same thing, easier one, you have to find the mathematical relation between these two. So 30 here. Okay, so just sorry. If I go here, suppose I have the matrix like 10, 20, 30, 40, 50, 60, 70, 80, 90. So if I draw the mirror image, it will be 30, 20, 10, 60, 50, and 40, and 90, 80, and 70. So I have to find the relationship between this. So in this position is basically, if I take it as B array, B matrix, if I take it as B matrix, so B00 is taking the value from A 0, 2. If you think why, if you think carefully, B01, that is 20, it is taking the value from here. That means A is 0, 1. And the last value 10, it is taking the value from B02 from A A0, 0. You can see the rows are not changing. You can see rows are not changing. I mean to say these values and these values are always same, because obviously 10 is not changing the row. It is in the same row, but in some different column. Obviously 40 will never go into the first row or the last row. It will stay in the same row, but it is changing the column value. So how it is changing? So 0 to 2, how it is happening, or 1 to 1, or 2 to 0. So if I write some conditions like B, I, J will be something like A, I, obviously the row will be the same, and J will be 2 minus J. Then it is satisfying the condition above. All the conditions are being satisfied here. If I write, so if I write 0 here, so it will be 2 minus 0, and it will be 2. You can see it is matching this criteria. And it is happening for first row. Even I can write it for the second row. Even I can write it for the last row. So there is no game between the rows. It is a game between the columns. So if I write J and 2 minus J, it is satisfying the criteria. But now from where this 2 is coming? This 2 is coming from 3, that is the size of this matrix. That means it is 3 minus 1. That is 2 even, but I can write n minus 1 minus J. So if it is 3, I will take 2. If the size is 4, I will take 3, kind of that. Okay, so this is the key line I have to write. If I copy this, and if I go to the compiler, and now the program is about the mirror image. So at this part, I will write Bij equals to AI n minus 1 minus J. That's all. I do not need to give any enter or anything. And here I can write A equals to B. And after that, I can print the mirror image of matrices, and I can print the A array, A matrix. Sorry. I am again and again saying array instead of matrix, but that doesn't matter, believe me. Okay, so both are same actually. The matrix is just a double dimension array. That's all. It is an array as well. Okay, you can call it array. So if I write 3, and if I take the input 10, 20, 30, 40, 50, 60, 70, 80, and 90, and you can see a mirror image like this. So 30 came into the first part, 20 here, and 10 into the last part. So it is a mirror image, what I was talking about. If I go to the slide once again, you can see here 30 in the first position, 20 in the second, and 10 in the last. The same output I got. So now if I go further, and if I try to solve much more complicated scenarios, so let me go into the next slide, and there would be more scenarios, more complicated scenarios. So the topic 2 of today is complex program, and this is the last topic. That is not a new topic, but it is something like the more complicated programs like this, matrix multiplication. And it is a famous one, believe me, it is a famous program where you have to take input two matrices and you have to calculate the multiplication. So first, let me take two matrices and I will pause the screen for a bit because there is no meaning to write the program in front of you. I will just take the input, and for the time being, I am pausing my screen. Yes, so I have already written the program. So what I have written in between. So enter the row of matrix 1 and enter the column of matrix 2 that is being taken under R1 and C1. And I have declared one new matrix with R1 and C1, the size. Enter the row of the matrix 2 and the row column of the matrix 2, R2, C2. And I have taken that another matrix called B with a size like R2 and C2, row number R2 and column number C2. So now, as per the application, when suppose take this example, as per the mathematical rules, suppose these are the two matrices like 1, 2, 3, 4, a size 2 by 2. If I write the size in between, so just give me 1 minute. If the size of the first matrix is 2 by 2, 2 row and 2 column, and the second matrix is something 2 into 3. What I'm trying to mean, number of row is 2 and number of column is 3. So as per mathematical rule, it is not a rule of computer. So these two has to be same. The column of the first matrix and the row of the second matrix should be the same. It is a mathematical rule. Okay, we have learned that in class 11, I guess. When I learned that, it was in class 11 when I started doing the mathematical operations of matrix. And the resultant matrix means after multiplication, the result will be like 2 into 3. From where this will come? If I draw that, so the row of the first matrix and the column of the last matrix, second matrix, it will form 2 into 3. So if I want to write all this into the codes, all these rules into the code, so I will do something like this. The column of the first matrix should, if it is not equals to R1, then obviously nothing is going to happen. I will simple cut, I will print multiplication not possible. It is as per the mathematical rule, I am saying again. Else, I will take the input into the A array with size R1 and C1. And after that, I will take the input into B matrix with size R2 and C2. And after that, I will introduce another third array in suppose C. And that will be from, as per the mathematical rules, as I explained just few minutes back, it will be from R1, a row of the first matrix and the column of this last second matrix, R1 and C2. So after that, I will write some code here to do the multiplication, and at last I will print R1 and C2 with size R1 and C2, the C matrix I will try to print. So that is the program I have already written. So now the main logic, these are just the input and output, the main logic I have to write now in front of you. So if I check, obviously, first I will go through the all places of the resultant matrix, that is C, and it will be I equals to 0. Obviously, I less than of R1, I equals to I plus 1. And same like for int j equals to 0, j less than C2 or less than equals to C2 minus 1, whatever you can write, j equals to j plus 1. And Cij will be filled up by something. Now, what will be when the value of I 0 and j 0? What will be what I will put inside C00? So if I check the slide, C00 is taking the value like 1 into 5 plus 2 into 8. So from where it is coming? If you already know the matrix rule, the mathematical rules, it will be helpful for you. If you do not know, it is a mathematical, but I'm not mathematical concept. I'm not a good mathematics teacher. So it will be something like that. The 0th row, all the elements from the 0 row and 0 column. For this one means for the second element means 0 row and 1 column. So here it will be like the second 0 row and all the values from the second column. You can see 0 row 1 into 6, 2 into 9 means these values are coming from 0th row 1 and 2, and 6 and 9 are coming from first column. Okay, I hope it is clear. If I take arbitrarily, if I take any value, say, if I want to make it more clear, suppose this value, this is the position, something like you can call this position as 1 0, first row and second column means row number 1 and column number 0, because row and column starts from 0. So you can check the values inside. The values are coming from first row and second column itself. If I underline this value 3 and 4, from where they are coming? 3 and 4. 3 and 4 are coming from here, the first row, because here it is written as first row, means row number 1. Here it is row number 1 coming from. And from where this 5 and this 8 are coming from? From column 0. All the elements of column 0. So column 0, let me check, it is here, 5 and 8. So in the similar way, if I explain, if I go to our code, where is our code? Yeah, here I and j means all the values from the ith row into all the values from the jth column. So all the values means, for I will introduce another elements which will take all the elements from these two, and it will be up to C2, because column 2 and R1 both are same. You can give any. Okay, so if I iterate from 0 to at last, and k equals to k plus 1, and what I will do, I have to take all the elements. Okay, so I can write something, sum equals to 0 here, and here I can write sum equals to sum plus a ik, all the elements of the ith row 1 by 1. Okay, and all the elements of the j column as well here. So it is, after that, after taking the sum, I can write Cij equals to sum. K will be changing inside this loop, and I and j, suppose it is fixed for the timing, it is 0. Say the value of I is 0 and the j is 0. So now when the value of I and j is 0, I will do the sum here and put the sum into Cij. Okay, so it will be k0 to C2 or anything. You can, sorry, not C2, it will be column of first matrix. Column of first matrix, not 3 times, it will be twice. The column of second matrix was 3. Here, if you check 5, 6, 7, 8, 9, 10, the column is 3. So either I have to go to column 2 or row 2. Both are same. We have already checked. So I will iterate it up to column 1. K equals to k plus 1, and k will be changing like 0, 1 and different values. So I will take all the values for ith row and jth column with the help of k. And at last, I will put that value into Cij, into the desired place. And at last, I will try to print the Cij. So if I now run the program, okay, I think one bracket I have missed. Yep. If I put that bracket here, yeah. If I run the program now, so suppose 2 row and column is 2 again. And for the next one, row of matrix 2, it is 2 row and column 3, say, and multiplication not possible. Okay, what I'm doing wrong? Let me check. C2 not equals to R1, but I have given C2 equals to R1. Okay, sorry, I have written it wrong. The column 1 with a row of 2. Column 1 with row of 2. Column of first matrix, as I explained, with the row of second matrix. Okay, now if I enter 2 and 2, and here 2 and 3. Enter the elements of matrix 1, suppose 1 and 2, 3 and 4, say, and the matrix of the elements of the matrix 2 is what I have given, 5, 6, 7, 8, 9, 10. If I write that, 5, 6, 7, 8, 9, 10. If I write that, you can, okay, I have done some mistakes in between. So it is exceeding the limit. I have to check where I have done wrong. R2, C2, these are correct. Row of first matrix and column of second matrix, perfect here. Here I am doing R1. Sorry, I guess this part is not good because the matrix C matrix will be having the size, I mean to say, what I explained, 2 into 2 is the first matrix size, and the second matrix size is 2 into 3. Let me think once again. 2 into 3. So the middle elements, I have to check this thing. And the size, at last, the size of the resultant matrix will be 2 into 3. That will be coming from the first part. So it is R1 and it will be C2. So R1 and C2. Now let me go to the program and let me check if I have written it correctly or not. R1 and C2 is correct. I equals to I plus 1. K equals to 0. K equals to C1. Okay, no, it is not good. K less than C1. Okay, now let me run the program once again. Okay, am I printing correctly? Yeah, printing is correct. I can see, but let me try once again. 2 into 2 and 2 into 3. Now let me insert 1, 2, 3, 4, and here 5, 6, 7, 8, 9, 10. If I write that, yeah, multiplication is correct. 21 in the first part. If I review, 1 into 5 is 5, 2 into 8 is 16, 16 plus 5 is 21. Yeah, fine enough. So the multiplication is correct now. If you want to try it in a mathematical way, obviously you can do that and you'll be getting the same result. Okay. So now after this complicated program, if I go further, and it is saying another tough program, that is the spiral way, printing in spiral way. So what is this printing in spiral way? If I draw something, it is something like you have to print in a spiral way. Means first you have to, first you have to go like this. After that, you have to go like this. After that, you have to go like this. After that, you have to go like this. And at last, like this. So if you go into the spiral way, you can see first 10, 20, 30, 35 has been printed. Then 65 and 95. And after that, 90 to 70 in the reverse order. And after that, 40 alone will be printed. And at last, 50 and 60 from the middle. So it has 4 parts. If you can check carefully, it has 4 parts. So first part is you have to print from the first line and from first column to last column. After that, you have to print it from here to here. And after that, from here to here. And at last, this part. And this thing will be repeated. So now if I want to write this program quickly, and before that I have to make some changes. So if I go to the program, and first let me delete all this. Okay, I will pause my screen for a while and I will remove all the unnecessary lines and I will write the fresh code once again. So I have taken the inputs like this row. I have deleted all the unnecessary lines, and the column into C. I have introduced one matrix like with R and C, and I am entering the elements into R and C. Okay, I have forgot to remove R1 and C1. It will be simply R and C. Now, if I want to print the whole all the arrays, all the elements here, I have to write some fresh code. But before that, I will take some variables like first row. First row is always 0, fr, say. After that, first column, that will also be 0. In last row, that will be r minus 1. And in last column, that will be c minus 1. Okay, what I'm trying to mean, if I take an example, 10, 20, 30, and 35, after that 40, 50, 60, and 65, 70, 80, 90, and 95, and here 11, 22, 33, and 44. So now, first row is here. Okay, just a minute. Here I will place the first column, and here I will place the last column. And here as well, I will place the first row, and here I will place the last row. So first time, I will try to print these elements 10, 20, 30, 35. That means first row, and the columns will be iterating from first column to last column. All the elements of first row, if I want to print them, I have to write one for loop. That is for int I equals to from the first row to, from the first column. You have to be careful. I have to also be careful while writing this program. So till the last column, I plus plus, sorry, not I plus plus, same thing, I equals to I plus 1 anyway. And system, because I have not shown you the meaning of I plus plus as of now, so I shouldn't use that. I am going gradually. If you are really starting from 0, obviously it will help you. So that's why I'm not writing I plus plus. I shouldn't write that. So print, here I can write AI, not I, always from the first row. And instead of writing the column, I will write I, because the column will be from first column to last column. Okay, I will print everything, and I will give one space. So it will print the first line 10, 20 from first column to last column of the first row. You can see in the code, first row is fixed and the column is iterating from first column to last column. And after that, whenever I am done with printing with the first line or the first row, I will move the first row into this position, because the first row has been printed. I do not need that once again. So after doing that, I can write first row will increase one part. Next, what I can do? Next, I have to print these lines 65, 95, and 44. Means first row to last row, all the elements of the last column. So if I try to write that, int I equals to first row, I less than equals to last row, I plus 1, and I want to print everything from the last column. So if I write it will be I, the row position will be changing, but it will be surely from the last column. From the first row to the last row, you can see here I have written I, and the last column will be fixed. So all the elements will be printed from the last column. So if I try to draw, so this line has been printed and first row came into the second position, and here this line is also printed. So after doing this, obviously last column will be shifted to this one, because the previous last column has been printed. All the elements has already been printed. So there is no meaning to keep last column in the last position. So now the revised position of the last column LC is this one. So what I will do in the program, I will simply write LC equals to LC minus 1. So now what I will do, I have to print the next line. So what is the next line now? So this is the next line. Means last row I have to print. I have to print the last row, means from the last column to first column, but last row will be fixed. So if I write this program again, for int I from last column to greater than equals to first column, I equals to I minus 1. And if I try to print system.out.print aij, not aij, last row, and the columns will be changing. So columns will be I plus space. Sorry, plus space. And here after this line, if I go to the program, after this line, obviously last row will come into this position because last row has already been printed. So if I want to write that here, so last row will be last row minus 1. So I have to be very careful. Again, I am checking from last column to first column, I equals to I minus 1, and the columns will be changing here, but the last row is fixed. I hope if you are listening carefully, I hope you are clear. So for the last part, here I should print 70 and 40 because I am going spiral. Okay, I am going in spiral way. So 70 and 40 means from last row to first row, and first column is fixed. Okay, the same thing I'm doing, the same type of thing, not the same thing, the same type of thing. So here, let me check again from last row to first row. So that means int I equals to last row and I greater than equals to first row and I equals to I minus 1. And here I will be printing. Let me check. Here, the rows are changing, but column is fixed. That is first column. So here I can write AI and the first column is fixed, obviously. So after doing that, I will just write FC equals to FC plus 1. The first column will be shifted because there is no meaning to keep it here now. So first column will be shifted into this position. Okay, now again, these 4 lines will be iterated, means now again this line, again this line, and kind of that. So this part will be iterating until it finishes. So here I can write something like while until first column is less than equals to last column, and both the things, first row is less than equals to last row, until they crossed each other. Until that part, I want to print all these things. So if I run the program now, okay, so now suppose enter the row is 4 and column also 4, say for the time being 10. First, let me check if it is working fine or not. If it is working fine, 10, 20, 30, 40, 50, 60, 70, 80, say 90, 11, 22, 33, 44, 55, 66, and 77. So it is something 10, 20, 30, 40 from the first line. Yeah, it is printing. Then you can see 80, 33, 77 here. Then it is printing 66, 55, 44 here. Then it is printing 90 and 50, 90 and 50. Okay, I have to put some spaces here. 60 and 70 here. And at last 20 and 11. So it is printing here. So it is now printing in the spiral way. I know this is a bit tough and complicated. I know that, but yeah, you have to practice that. Otherwise, you will not be able to go further. You have to adapt these ideas. Okay, so now the last program for the day is rotate anti-clockwise. So you can see here 10, 20, 30. If you are rotating it in anti-clockwise, what does it mean by anti-clockwise? If you rotate it in this manner, so you can see 30, 60, 90, this line will come into the first. Obviously, you are rotating it anti-clockwise. So same 20, 50, 80 is coming into the second line. Here 20, 50, 80 is in this position. So you are rotating. Just try to visualize that. Okay, just try to visualize that. So now I have to find how it is happening. Again, I have to find the relationship between that. If I take, suppose if I am taking it as A array, A matrix or A array, whatever it is, just a minute, yeah. And if I'm taking it as second one output as a B array. So what is happening? So B00, B00, suppose if I'm writing in this way, B00 is coming from, means 30 is coming from A 02. Now 60, B 01 is coming from A 60 is coming from 60 is coming from this position. So this position is, if I want to write, it is 1 and 2. I'm not that good in mathematics as well. It always takes some time for me to understand things. I'm a slow runner as well. I have explained a couple of times that. So probably you are thinking I am taking much time to think over the positions, but yeah, I always take some time to understand. So for 02, that is, sorry, what happened? Just a minute. What is my, where is my, okay, just a minute. If I make it large, sorry, I need the example. Okay, now I was in the 02 position. 02 means 90, I guess so. Yeah, 90. And 90 is coming from A to 0. No, A to 2, right? If I delete all the drawings, 90, simple cut, 90 here in the B matrix is coming from here. I am writing correct way, I guess so. B02 is coming from A02, I guess so, yes. So now if I take 20, this 20 in the B array is coming from here in the A array. So that means B, let me think slowly, B10 is coming from A01. So now what to do with this? How I can write Bij? So Bij should be, if you check closely, these two parts are same. These two parts are same. So I can simply write Aj here, obviously. And these two part is like previous. If I, sorry. So up to this is okay. Now, if I check these parts 001 and 221, if it is like the previous, so I can write something called 2 minus I. Means if I write B1, B suppose 0 and 2, from where it is coming. If I take a look, so I can put J here, means A2 here, and 2 minus I here, means 2 minus 0, that is 2. You can see this line is matching with this line. So this rule is correct now. So I can simply put this rule, into the code. So you have to just draw, you have to derive some mathematical calculation. That's all you need to do. So enter the elements. Obviously, I do not require all these lines because that was the toughest program, I guess. So now what I can do, the same loop, and I will write something called Bij equals to Aj, something this. And I obviously I have to introduce a B array as well. So int B equals to mint. R and C here I am considering as a square matrix. Okay, let me take a square matrix here. You can do it in another way as well, but I do not want to make things complicated for the time being. I am going gradually. So I think taking square matrix will be easier for you. So A and B, N and N. So here as well, enter the elements N. Here as well, enter the elements N. Aij input. Okay, now I am doing the rotation here. So I have just derived it from some mathematical calculations, what I have checked. Now I will simply print, like I can write something. Rotated matrix is and I can write, I can print. Okay, I can do one thing as well. I can either you can print B array, or you can also simply do like A equals to B, and you can print the A array itself, A matrix, sorry. Yeah. Print I hope this is clear. If I run the program now, if I have done everything correctly, okay, sorry, I can still see it is RNC. All will be RNA, all will be N. And I think, okay, something I missed, like giving semicolons. Yeah. Now, if I run again, the last program for the day, just have some patience with me for another 5 minutes. Say. So suppose if I write 3, say, and enter the elements of the matrix 10, 20, 30, and 40, 50, 60, and 70, 80, 90. So the matrix will be look like something like this: 3, 30, 60, 90 in the first row, 20, 50, 80 in the second, and 10, 40, 70. So I think we have covered this rotation as well. So now if anyone asks for multiple time of rotation, obviously you know the way now. You can put this rotation box inside another for loop, just like the first program we did. In the first program, I think in one program we have done like, no, the second program, shifting up. And after writing the program of shifting up, I introduce another loop at the starting, and that loop is helping to repeat those steps multiple times. So if anyone is asking for rotation for 2 times, 3 times, or n times, I would suggest to give some for loop here in this line on the top of this for loop. And this will help you. I'm not doing that for you. I will prefer if you can write the same program in your computer. I'm not going to write that anymore. So I hope, yeah, that's all. If I go further, I think will be nothing else. Yeah. So that's all for the day. And I will request you to cover the matrix chapter from the intermediate one, front-end exercise, the intermediate, because these are some tougher problems. So go through that and try to solve all of them for the time being. And next day, I will meet you with some new chapter. Okay. So practice more and it will be okay for you. Trust me. Bye for the day.